Problem 3 talks about a chessboard and you putting a dime on each numbered square. I decided I'm not going to read you the question. I'm just going to put in the description in case you want to read it. So I'll just dive into how to get the answers. So first, what you need to do for part A is find out how many dimes you're going to stack on each square. And rather than saying, like this, I'm going to count 1 for one square 1, 2 for 2, 4 for 3, etc. We need to come up with some sort of smarter formula. And you can do this one of two ways. So I saw that Emily did it where she did y equals 2 to the n minus 1. And mine's a little bit different. So I use the y equals a plus b to the n formula. So I just used 0.5 for a and 2 for b. And the reason why the formula spit out the same thing is because when you do n minus 1, basically what you're doing is removing a factor of 2, which cuts it in half. So by putting back that factor of 2, you have twice the value, but by adding this coefficient of 0.5 to it, you cut it back in half again. So you'll get the same values with either formula. So now that we have our formula, we just plug in 10 to figure out, or any number that we want to find out how many dimes are on there for. And we get 0.5 times 2 to n, we get when n is 64, y equals 9.2 times 10 to the 18, which is just 1 with 18 zeros. When n is 10, y is 512. And then the next thing it asks us is at 1 millimeter, how many dimes will be, assuming a dime is 1 millimeter thick, how high will the last pile be? So all we have to do is multiply 1 millimeter by 9.2 times 10 to the 18, because we know that n to the 64th. When n is 64, we have 9.2 times 10 to the 18, and then we know that we have that many millimeters. So then to do a millimeter to kilometer conversion, I think I did this a little bit different than Emily as well. I did 1 times 10 to the 6 millimeters per 1 kilometer. You can write that with the kilometer on the numerator or the denominator. It's just a ratio. And so you just multiply 9.2 times 10 to the 18 millimeters. And then whatever you want to cancel out, in this case we're trying to convert millimeters to kilometers, so we're canceling millimeters. Put it on the denominator of the ratio. You have 1 times 10 to the 6 being divided into 1 kilometer. I wrote 1k there by accident, especially 1 kilometer. And what you end up getting is 9.2 times 10 to the 12th. You basically just subtract 6 from 18. And then I wanted to ask myself how many millions of kilometers that is, because we were given the distance of the sun in millions of kilometers, 1.5 million kilometers. So we do the same kind of conversion where we say that we want kilometers per 1 million. So we just end up with 9,200,000 millions of kilometers. And we compare that to the sun, and I said that you can make it there and back. I just divided this by 2, which now that I'm looking at it, actually looks, I think it's wrong, so maybe ignore that. But what I was trying to get at was you would make it there and back in so many times. I think that number's wrong, but there you have it. Thanks.